Good evening, everyone.
Good evening,
Good
sir.
evening, sir. Good evening.
एक मिनट defocus. So I'm going to discuss with you next part of your syllabus. We have discussed already kinetic theory of gases and thermodynamics. Okay, that part we have already covered, and now uh, it's time to discuss the next part, and that part is this statistical mechanics. Okay, so I told you that this will be very important part as far as number of questions asked are concerned, because from thermodynamics part only two questions are asked, and this part rest of the questions are asked from this part. Okay, and for every exam this will be very important. In all of your exams this will be very important. Okay, so let me give you a little outline of what I will be discussing in your statistical mechanics. This will start from uh, probability calculations, and with brief introduction of the topic. Okay, so you can write like this: introduction and then probability calculations. Okay, this will be the first part in which I will give you a brief introduction of the topic which we are going to study, and we will discuss little bit the history and the scope of the topic. Okay, the next thing will be uh, the second part will be about the uh, systems, about the systems, different kind of systems that we are going to study after this probability calculation. And in system we will discuss uh, just give me a second. So actually in the first part, in the introduction part, I will tell you about little bit I told you in kinetic theory of gas also about the concept of averages. So I told you that the concept of statistical mechanics has already started in the discussion of kinetic theory of gases. There I told you about the calculation of different type of averages. So that I will discuss here in the first part. Then in systems, we will have three kind of systems. First will be microcanonical. So I mean, we will discuss different type of systems. So first type will be uh, different type of ensembles. Actually, I will tell you what is ensemble. This is the scientific name that I will be using. So microcanonical ensemble, and then canonical ensemble, and the C part will be grand canonical ensemble. Okay, and These all discussion will be from equilibrium statistical mechanics. Okay, so the terms are very important. So we will clear each and every term, whatever we are going to discuss. I will try to make clear to you all of the terms. Okay, so in equilibrium statistical mechanics, we will discuss all this: microcanonical ensemble, canonical ensemble, grand canonical ensemble. This all three will I will discuss. And I must tell you that this part is so major that some three questions are asked from only this canonical ensemble. So this part is very, very important. Okay, so after this discussion, I will come to phase transition. And under phase transition, I will discuss first order phase transition A, and B is second order phase transition. Second order phase transition. Okay, so I will discuss first order phase transition and second order phase transition. And under second order phase transition, I will discuss the Ising model, and I will also discuss Ginzburg-Landau. GL लिख लो शॉर्ट में, Ginzburg-Landau phase transition. Phase transition. So I will discuss this Ising model and Ginzburg-Landau phase transition. Okay. And finally, I will discuss little bit about non-equilibrium statistical mechanics. And we will discuss a tool here that is known as binomial distribution that I will be using in non-equilibrium statistical mechanics. I will discuss the concept of diffusion. Okay, because diffusion is a non-equilibrium phenomena. And this I will discuss random walk problem, Brownian motion, etc. This all I will discuss. One Einstein's model also I will discuss. You can write here Einstein. Another scientist is some S, tough name. Einstein S model. Okay, that I will also discuss finally. Okay, so this is the complete outline of the syllabus that I am going to cover for your net, gate, jest, TIFR, and uh, other central universities, for example JNU, etc. Other central universities. So this is the complete syllabus that I am going to discuss. I repeat that the idea of knowing the overall syllabus is very, very important, because that gives you the insight कि कैसे प्रिपेयर करना है, कहाँ फोकस करना है, ये सब कौन बताता है. अब जैसे देखो पिछले कई एग्जाम से गिन्सबर्ग लैंडौ फेस ट्रांजिशन से क्वेश्चन आ रहा है. अगर आपने पढ़ा नहीं है तो आपको लगेगा, पता भी नहीं चलेगा किस टॉपिक का क्वेश्चन है. ओके, सो आइजिंग मॉडल है, जैसे गिन्सबर्ग लैंडौ फेस ट्रांजिशन है, कैनोनिकल एंसेंबल है, यहाँ पे ब्राउनियन मोशन है, डिफ्यूजन है. सो ऑल दिस वी विल स्टडी in coming classes. Okay, so is there any doubt or any confusion about the syllabus, you can ask in very short time, quickly.
Sir, any reference book?
Ha, thank you. I actually forgot. So uh, I use three books to teach you. One is Reef. Okay. Next one is uh, पाथरिया आर के. ये पहला वाला लेटर नहीं याद आ रहा था. जब आपने पाथरिया बोला तो मुझे आर के भी याद आ गया. आर के पाथरिया. एंड थर्ड वन इज लैंडेव.
सर पहला
पहला रीफ. अच्छा, मैंने रीफ की साइन ही बना दी. रीफ जैसे साइन करते होंगे वो बना दिया मैंने. ओके. So these are the reference books. Reference books. But I must tell you with all confidence that the notes which you will develop with me and the amount of problems you will solve with me will be sufficient to do problems in your exam. Okay? ठीक है ना? So because you know काफी टाइम टेकिंग हो जाता है बुक्स में जाके पढ़ना. तो लैंग्वेज भी ऐसी होती है एंड कोई बहुत ब्रीफ बुक नहीं है इस पे. शायद ब्रीफ में बताया ही नहीं जा सकता. मतलब मुझे तो बताना पड़ता है बिकॉज सिलेबस की टाइमिंग है. बट अदरवाइज सारी बुक्स में वो डिस्क्रिप्शन इतना ज्यादा है कि समटाइम्स दैट बिकम्स वेरी वेरी टफ टू हैंडल. हाँ, बट बी कंफर्टेबल. आई विल टीच ईच एंड एवरीथिंग एंड साथ साथ आप अंडरस्टैंड भी करते रहोगे. दैट विल नॉट बी अ प्रॉब्लम. ठीक है. एनीथिंग एल्स यू वांट टू आस्क?
Sir,
Fluctuation is not a separate topic actually. That will come within that. We will calculate fluctuations.
Okay, sir.
अब भाई ये तो वो
Okay,
बात हो
sir.
गई कि मैं यहाँ पे लिखूं कि एवरेज एनर्जी, ERMS एनर्जी. दैट आई विल नॉट राइट ना.
Okay, sir.
Direct and Bose-Einstein. The Fermi direct.
हाँ, that two things more. So identical particles. Thanks for that. So we Maxwell Boltzmann we have discussed already na, and Fermi Dirac and Bose-Einstein. So these three distributions also we will discuss.
The diamagnetism, paramagnetism part also.
No, that is not a separate part. Not a separate part. Not a separate topic. So I am not telling you the topics inside the topics, na, broad topics. For example, diamagnetism, paramagnetism, all we will discuss this in canonical ensemble. Okay.
Yes.
So let me proceed now. You have taken it down. This is very important on the first page. Keep a track of this while my teachings. You can keep a track of this कि भाई सारी चीजें अच्छे से चल रही हैं. Okay. चलो आगे बढ़ते हैं. So write the first name of the first topic that we are going to discuss. What is that?
Probability.
Sorry.
Introduction.
Yes. So write introduction to statistical methods, probability calculations. Calculations. Introduction to statistical methods, probability calculations. Okay. So actually what we are going to discuss, आपको ये तो देखो, ये आपको दिमाग में क्लैरिटी होनी चाहिए कि कोई भी आप टॉपिक पढ़ते हो, क्लासिकल मैकेनिक्स, क्वांटम मैकेनिक्स, स्टैटिस्टिकल मैकेनिक्स, थर्मोडायनेमिक्स, आप किसी सिस्टम के बारे में समझना चाहते हो, यू वांट टू अंडरस्टैंड अ सिस्टम, सो दीज आर डिफरेंट अप्रोचेस. ये क्या है? दे आर डिफरेंट अप्रोचेस टू अंडरस्टैंड द सिस्टम. इज दैट मच क्लियर? that there are different approaches to understand a system. So now my discussion is about a many particle system. Be clear about this. हम लोग जो अभी डिस्कस करने जा रहे हैं, what type of systems we are going to discuss? We are going to discuss many particle system. ऐसा सिस्टम जिसमें बहुत ढेर सारे कॉन्स्टिट्यूएंट्स पार्टिकल्स हो सकते हैं. ओके okay? अब इसको ब्रॉड तरीके से दो पार्ट में डिवाइड किया जा सकता है. वन कैन बी यू नो सिंपल calculation of interaction between the fundamental particles, you can say. So because that is also a many particle system, many nucleons are there, many proton proton interaction, neutron neutron interaction. So one type of interaction is between the fundamental particles. Okay, so that is governed by fundamental forces and fundamental forces between the, say, between the nucleons. So here the difficulty is something else. The difficulty is that the profile of the force between the two particles is not simple. That is very difficult, and you know different models are there. This part we study in which physics? Particle physics. Particle physics. So that, I think, मुझे पता नहीं है if that is completed or that will be taught to you about the particle physics. ठीक है? Hello?
No, sir. Next.
No, sir,
हाँ.
not till.
So that will be discussed. ठीक है? This is not my part. This is not my territory. So second thing is about the many particle systems is gases, liquids, solids, plasma, biological systems, etc. So these are also many particle systems. For example, gases have large number of molecules, liquids have large number of molecules. Are you aware of this now? Solids have large number of molecules. Then plasma, that has also large number of constituent particles. Then the biological systems, they also consist of large molecules and large number of molecules. Okay, so our interest is to apply the statistical method on few of such systems. So we will develop methods that can explain the properties of such a system. Okay, the second part. So many particle system में हम लोग we are interested in this part, जिसमें ऐसा नहीं है कि हम प्लाज्मा पढ़ने जा रहे हैं, ये बात ध्यान रखना. हम लोग थोड़ा गैस और लिक्विड पे अप्लाई करके देखेंगे our statistical systems. Most of the time it will be a gaseous system, but sometimes it can be other systems also. Okay, but same idea is extended. Same idea is extended to these systems. Okay, थोड़ा बात समझ में आई? So the many particle systems, a system is like this. So can I erase this?
Yes.
Yes, sir.
Okay. Now let me quickly tell you that when I say the statistical method, it is actually, when I say statistical mechanics, so what we are going to do, let me try to explain कि ये subject है क्या. Subject ये है कि you have a many particle system. So इसीलिए मैंने बोला था kinetic theory of gas model is very very important, because जब भी कोई system सोचना हो, you can think about that model consisting of large number of particles. Okay, consisting of large number of particles. So statistical mechanics means we will apply the statistical approach. Statistical approach, ये mathematics का word है. What do you mean by this? Method of averages. You know different type of averages I have discussed: mean, then RMS, most probable, etc., etc. So we will apply methods of averages and probability. Spelling सही है? Probability. Okay. Methods of averages and probability, and the second word is mechanics. So we will also apply some laws of mechanics. Laws of mechanics. So this together will constitute a method to understand the system. ये बात आप बस हमेशा किसी भी सब्जेक्ट को लेके बहुत ही सिंपल वर्ड्स में क्लैरिटी होनी चाहिए कि व्हाट इज दैट सब्जेक्ट अबाउट, व्हाट इट डज, क्या करता है. कम से कम एक छोटा एग्जांपल तो दिमाग में हो. तो आपने देखा कि ऐसे अगर गैस मॉलिक्यूल्स हैं इतने ढेर सारे, उसकी क्या प्रॉपर्टी बता पाओगे? बट यू हैव सीन कि कैसे काइनेटिक थ्योरी ऑफ गैस मॉडल में यूजिंग द स्टैटिस्टिकल टूल्स ऑफ एवरेजेस धीरे 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 करके कैसे हमने उस गैस की स्पेसिफिक हीट को अच्छे से समझ लिया, विच इज अ मोस्ट इंपॉर्टेंट thermodynamic property of that system. Okay, so statistical mechanics will also be an approach to understand the system and why we can apply the statistical method. Question arises that. So see this example, because the bad thing and good thing about this system is it consists of large number of molecules, because even a mole of molecules will be very very large number of molecules. और आपको पता है जहां पे लार्ज नंबर आ जाता है स्टैटिस्टिकल अप्रोच अच्छे से काम करता है. एग्जाम्पल इज कोई भी एवरेज, चाहे वो ओपिनियन का हो. सपोज इलेक्शन का आपको एक ओपिनियन समझना है कि कंट्री का मूड क्या है. सो इफ यू ओनली, आपने अपने दोस्त से पूछा भाई कौन जीत रहा, उसने बता दिया, बस हो गया क्या? नो, बिकॉज दैट इज वेरी वेरी लेस number and statistical method works on large numbers. इसीलिए आपने देखा होगा, you must have seen that large sample survey is carried out. वो भी बहुत डिफरेंट डिफरेंट टाइप के लोगों से, कुछ टीचर्स सेलेक्ट कर लिए, कुछ बिजनेसमैन सेलेक्ट कर लिए, कुछ ऑटो वाले सेलेक्ट कर लिए, कुछ पान वाले सेलेक्ट कर लिए, कुछ किसान सेलेक्ट कर लिए, कुछ गवर्नमेंट एम्प्लॉइज सेलेक्ट कर लिए. समझ रहे हो ना आप बात को? टू डाइवर्सिफाई द आइडिया. वही हम यहां भी करते हैं. दैट इज द कॉन्सेप्ट ऑफ एनसेम्बल. वी ऑल्सो मेक मेंटल कॉपीज ऑफ small systems, and we take a large number of mental copies, like we did in the case of calculation of average velocity in kinetic theory of gas model. अगर आपको याद हो, G groups में divide कर दिया था. We divided that into large number of groups, G groups, to calculate the average. Okay. So or laws of mechanics, for example, Newton's laws. For example, Newton's laws. And laws of mechanics can also be quantum. This is classical one. Then we can also use mechanics, quantum mechanics. We can also use quantum mechanics. Okay. So this is statistical mechanics. It uses both classical mechanics as well as quantum mechanics to find out to understand the system. So just to understand this system, to understand the system, its properties, and to make predictions, good predictions, that is our goal. कि हम सिस्टम को उस लेवल पे समझने लगे कि हम सिस्टम को की प्रॉपर्टीज को समझ सकें, एंड वी कैन मेक प्रेडिक्शंस अबाउट द सिस्टम. जैसे फॉर एग्जांपल, आपने अच्छी क्वालिटी की, यू हैव डन अ गुड क्वालिटी मैथमेटिक्स एंड फिजिक्स, एंड यू टेल below this temperature most of the atoms will be in ground state. So that is a prediction, na? That is a theoretical prediction, and that is seen experimentally also in Bose-Einstein condensation. I am giving you an example. So, and for example, we made predictions about the degree of freedom. Low energy, only translational, then rotational, then vibrational. So all that is because of the understanding of our system. Okay. So this is overall kind of preamble of statistical mechanics, that how we are going to proceed. But you have seen that we need statistical methods and probabilistic calculation. And statistical method means method of averages. सारे averages हमें अच्छे से clear होने चाहिए. Method of averages that we are going to deal, and as well as the method of probability that we are going to deal. Okay. ठीक है? Anything you want to ask? In 1 minute, less than 1 minute, you can ask.
So these particles are interacting or non-interacting?
Forget about that. That depends on the kind of system. We will discuss both. We will discuss non-interacting particles. We will discuss interacting particle. If you want to discuss interacting particle, you should know the profile of the potential. आपको पता करना होगा किस type का potential है. Potential means an interaction.
Yeah.
So both type. I have written in general. I have not specified this because this is a very big subject, na? So you can't say that only interacting will be discussed or only non-interacting. It actually, we can discuss equilibrium as well as non-equilibrium, both type of statistical mechanics. Interacting, non-interacting तो बहुत छोटी बात है, वो तो उसके अंदर ही आएगा. ठीक है?
Yes, sir.
Anybody else?
Hello, sir.
हाँ.
Sir, what is plasma?
Plasma, solid, liquid, gas, and then you heat gas up to certain temperature. So all of the constituent particles float together, and that, you know, that consists of electrons, obviously, electrons and positive charges. So that state is known as plasma state. For example, your sun and 99% of the universe is in plasma state. Okay.
Thank you, sir.
Sir, excuse me, sir.
हाँ, जल्दी जल्दी अब next.
Sir, here you are considering about the particle number of particles, sir. Like we are considering about any region that number of particles are like that. Like this small, this much amount of particles must be there in that region, like that. Constantly.
No, 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 you can't say that. Large number of particles should be there to apply statistical mechanics. If you will take very, very small amount, that means the results will not be good.
Okay.
Okay. So now let me discuss little bit about the size of the systems, and two different terminologies are used for that. So let me quickly discuss that. And then I will take some systems to discuss. So the sizes of the system. Okay, the sizes of the system. So the first one is the microscopic, a microscopic. Okay, and you can see in the name itself, micro, that comes for 10 to the power minus 6. Okay, that means very small. यहाँ पे उसका मतलब है small scale. Okay, so they say that this kind of system should have roughly atomic dimensions. Atomic dimensions. That means at the level of atoms, etc. That means roughly about 10 angstrom. Okay. So this means for this system, just a second. For this system, if you want to discuss microscopic things, that means you have to go up to a level of atom. For example, hydrogen atom is there and it is floating in your medium. So you are writing the equation for each and every particle. Okay, so that is microscopic level of understanding. Okay. Second is macroscopic. So in this, we see overall picture. We don't go to that level, to microscopic level. Please write quickly. System in this case is large enough. It is visible. Okay. System is large enough. It is visible. And we can say that it is greater than 1 micron. Okay. So there is no clear cut, you know, distinction, because you know जो size है वो तो एक relative चीज है, इसलिए एकदम 100% माइक्रोस्कोपिक और मैक्रोस्कोपिक आप डिफाइन नहीं कर सकते. बट ये जो मैंने एक सिंपल सा केस लिया था जिसमें सपोज देयर वर मैनी पार्टिकल्स लाइक दिस. It was a many particle system. So if I write equation for each and every particle, that is microscopic, that means knowing the profile of one particle in this is like knowing the microscopic behavior. But suppose I just know the temperature and volume, such parameters, or thermal conductivity, okay, so that will be macroscopic parameter. Okay, so sometimes it is not necessary to know all the details at microscopic level. So please write example of macroscopic parameters are volume, pressure, magnetic moment, temperature, etc. Yeah, thermal conductivity. All these are macroscopic parameters. So that's why when I derived, if you remember, when I derived this kinetic theory of gas equation, in which half mr mvrms square was equal to 3/2 kbt. आपको याद है ये वाली equation?
Yes, sir.
So this vrms is the story of a particle. It is average velocity kind of. RMS is also a kind of average, root mean square average. So this is average velocity. That means information about one particle. And this is a macroscopic parameter, temperature. It tells. So the macroscopic parameter temperature has all the information, microscopic information available with this. So that is the benefit of temperature. Sometimes you don't want to see what is happening at molecular level. जैसे आपको फीवर हो जाता है, तो फीवर हो रहा है तो कहीं ना कहीं मॉलिक्यूलर स्पीड्स बढ़ रही होंगी. At molecular level what would be happening? कोई रिएक्शन हो रहा है या कुछ समथिंग इज हैपनिंग. उस पूरे डिटेल के बारे में जस्ट टेम्परेचर सोचो कितना सिंपल मैक्रोस्कोपिक पैरामीटर है कि वो तुरंत बता देता है देयर इज सम प्रॉब्लम. देन यू स्टार्ट सर्चिंग फॉर इट कि व्हाट इज हैपनिंग. सो आपके पास एक बॉटल, एक वाटर है अगर सपोज बकेट में, एंड व्हाट इज हैपनिंग एट मॉलिक्यूलर लेवल, द स्टोरी इज in macroscopic parameter, that is known as temperature. You agree with that?
Yes, sir.
Like other parameters, for example volume. Suppose you have a balloon, you are pushing more molecules and the volume is increasing. So macroscopic parameter is telling that has some connection with the microscopic level, the inside story, what is happening. ठीक है ना? तो ये माइक्रोस्कोपिक और मैक्रोस्कोपिक ये बहुत ज्यादा यूज होता है बार बार. और एक इक्विलिब्रियम वर्ड बहुत ज्यादा यूज होता है, आपने देखा होगा ना, इक्विलिब्रियम. व्हाट इज दैट? प्लीज राइट क्विकली. इफ मैक्रोस्कोपिक पैरामीटर्स, if macroscopic parameters of a system are not changing with time, if the macroscopic parameter of the system is not changing with time, it is equilibrium. Okay.
Sir, macro.
Sorry. Like suppose temperature is not changing with time. So that means thermal equilibrium. If temperature is not changing with respect to time, that means it is thermal equilibrium. Okay. So there is thermodynamics, which is the earliest branch. Then came statistical angle, क्योंकि probability average introduce कर दिया किसने? बोल्ट्जमैन. याद है ना? मैक्सवेल बोल्ट्जमैन. Velocity distribution पढ़ा ना? Probability distribution. So then Maxwell, and then finally the branch developed, and the first very serious attempt to consolidate that was done by Gibbs. ठीक है, उन्होंने एक बहुत अच्छा पेपर भी लिखा है, गिब्स का पेपर भी है स्टैटिस्टिकल मैकेनिक्स पे, जिसमें उन्होंने पोस्टुलेट्स एक्सेट्रा डिस्कस किए हैं. So that is 1900. So you know, early thermodynamics started from 1798. This was the time when thermodynamics started, and the Gibbs came in 1902. And Boltzmann came in 1872. So you can see that how things developed. So this was pure classical thermodynamics, CT. And then this was Boltzmann time. You know the contribution of, and this is Gibbs time. Okay. So this is how the statistical mechanics discuss. और ये सब equilibrium statistical mechanics है. What about non-equilibrium? So you know, Einstein का वो जो paper है, that all is after 1915, 16. Okay. And today also non-equilibrium state, because you know parameters are changing with time. We are interested in such a systems where the number is also the the macroscopic parameter is also changing with time. So वो काफी difficult हो जाता है. So that is known as non-equilibrium statistical mechanics. Even today also that is called in its childhood. अभी वो डेवलप्ड ब्रांच नहीं है. सो मोस्ट ऑफ द रिसर्च एरिया ऑफ स्टैटिस्टिकल मैकेनिक्स इज इन नॉन इक्विलिब्रियम स्टैटिस्टिकल मैकेनिक्स. जैसे डिजीज का स्प्रेड है, अब आप एक देखते हो कोई इक्विलिब्रियम तो आया नहीं है. 2 से कभी 4 हो गए, कभी 4 से सीधा 50 हो गए. समझ रहे हो ना? देयर आर सो मेनी पैरामीटर्स वर्किंग. सो ऑल दिस इज the study of such systems is under non-equilibrium statistical mechanics. So अगर आप में से कोई कभी रिसर्च में जाना चाहेगा इस फील्ड में, तो पूरा जो बायोफिजिक्स का एरिया है, that is all based on statistical mechanics, जिसमें हम random walk problems यूज करते हैं, Monte Carlo simulation यूज करते हैं. तो काफी ज्यादा कोडिंग का काम होता है उसमें, और then you predict a system. Okay. So the you know, एक फाइनल बात जो इंट्रोडक्शन में मैं बताना चाहता हूं कि सपोज दिस इज अ सिस्टम एंड यू नो द डिटेल्स ऑफ ईच एंड एवरी पार्टिकल. Suppose you can write the equations of each and every particle, interacting or non-interacting. Forget about that. You can take any type of system. Suppose you apply quantum mechanics, so you can write wave functions corresponding to each and every particle and all sort of average things. But still, knowing the interaction is one thing. ऐसा नहीं है कि आप पार्टिकल का इंटरेक्शन समझ गए तो सारी चीजें बहुत आसान हो गई. तो स्टैटिस्टिकल मैकेनिक्स इसलिए भी इंपॉर्टेंट है कि इवन दो यू सिंपली नो द इंटरेक्शंस, इट इज नॉट इजी टू प्रेडिक्ट द बिहेवियर ऑफ अ सिस्टम. सो जो प्रेडिक्शंस आप कर पाते हो स्टैटिस्टिकल मैकेनिक्स में, दे आर वेरी वेरी इंपॉर्टेंट. आई विल गिव यू वन एग्जांपल. सपोज कोई गैस है और आपने प्रेशर बढ़ाना शुरू कर दिया, तो किसी पर्टिकुलर पॉइंट पे आके दैट गैस विल बी कन्वर्टेड इनटू लिक्विड. The prediction is not easy, even though you know the van der Waals forces acting between the molecules. Are you understanding? So such difficult predictions of complex systems can be made using statistical mechanics. So now this was kind of, you know, introduction which I wanted to give you, and then I want to discuss some different type of systems. So what is the timing? It is started from 5:50 then?
Then
It's
6:40, 45, 6:45.
6:40.
6:40?
Yes, sir.
6:40.
Yes, sir. 40.
Okay, okay. So let me stop here, and then अभी ये थोड़ा सा outline समझ में आ गया? If you have any doubt, quickly ask, and then we will take some systems and actually discuss all those probability, average, and that kind of thing. पहले वो सिखाऊंगा. That is kind of tool of statistical mechanics.
Clear, sir.
Clear है, very good. So let us stop here, and then 10 minutes में या 5 minutes कितना है?
10 minutes.
Okay, okay. Let us meet again.